Hello there, and welcome back. Well, not really back. Nobody's watched the last video yet, and I'm already starting on the next one, where I've made quite a lot of progress, it turns out. Now, what I've done is I invented a kind of what I call a graphics object. Now, I'm trying to keep things as simple as possible. It's not pure virtual. I want them all to be rectangle objects because I can work easily with rectangle things, moving them around and so on. This is something that I put in anticipation of, some kind of animation or something later on. But in fact, nobody's using it at the moment, so we'll get rid of it. The only one requirement for someone who wants to be a graphics object is to implement this draw. So draw yourself to a D context, one of my D context things. Now, you'll notice that the default constructor sets the rectangle of the graphics of a graphics object to be the full size of the screen, and that would remain the case unless somebody decided to change the size of the rect by calling this set rect. It's funny. I suppose this has a set rect. I've been implementing set rect. Sometimes you don't need it. Okay, well, in any case, from this graphics object thing, I invented two things. One of them called a text control, which has characteristics that most text things have, either a foreground color, a background color. This is a shadow color, if there happens to be a shadow. And then there's this background mode. So there are quite a few. There are more variables here than would be needed. I could split it up into two classes, I guess, but I don't think it'll grow much more than this. If there if the background mode is transparent, then there's no need for a background brush. It's transparent. If there is a background color, then you can't have a shadow, really. Well, I guess you could have a shadow, as long as the shadow color is different from the background. Okay. Now I got into a little bit of trouble with I had to put this operator equals here because I wanted to be able to set the text just by assigning the text to the text control, but then I got into trouble putting two assignments on the same line, so I gotta watch out for that. That is, it didn't fail, it compiled and ran, but the outcome was that all of the data got wiped out. So I have to disallow that possibility. Now, to simplify things, one text control can copy the attributes of another, and so it saves in typing. The other one here I have is a line, which has a pen and 2 points. Now you can construct one with those all of the bits of data, or you can do it separately. I happen, for the one line that I have currently, I do them separately. So now here I have one line and a whole bunch of text boxes. Okay, not nude or deleted or whatever, but I keep a list of pointers to these controls in this list here, so that if I need to redraw the entire, redraw the screen, I can always just run through the list and draw everything. Now, not much to see here. It's most of the work is done in WM Create. Set the client rect to magic 800 by 600. Now, this comes from quite a long time ago. I don't know if you recall. This TSDIB, that would be Device Independent Bitmap, is a class that I created in order to be able to create essentially a memory device context, right? And it can be created not without files or anything. You just give it a rectangle and a bits per pixel, 32 I chose, and call this create function, and that returns you a smart pointer type object. So this can be copied around. Now that, go back to the header file, is then used to fill in this member TSD context. This is a D context for the HDC that is in here. Instead of writing over and over again, declaring one of these and then attaching it to the HDC, I just do it once because it's never going to change, so we might as well have one variable. Now I create a brush. This brush is for the background color, no pen. I do the one and only attach of HDC to my device context, and set the there's a member of TSD context called setRect, and that defines essentially the area or the dimensions of the device context. That rect can actually change. I mean, when there's clipping and stuff, but that never happens in this case. Okay, so now if these calls were successful, the objects are selected into the memory device context, and now I'm building my little control things. So first text control says goodbye world. Foreground, I'm starting to build a color table. White foreground, opaque background, that means not transparent, so it needs a background color, which I don't think I'm even setting, am I? It'll default to black. So I'm taking the default. Now here I'm taking advantage of the fact that I added a little function here that can calculate the rect that would be occupied by this string. So I'm setting its rectangle in this box equal just big enough to hold the string. And now, since all of these things are rectangles in themselves, I can use my 9 famous functions. Upper center, I move it upper center with respect to the client rect, and then down 10, so it would be near like a title. Now there's something called cursor pause, which you saw before, prints out the current position of the cursor, which I've taken the attributes of this from, so I have the same white on black attributes as this, and I just randomly chose a rectangle that I know is going to fit. Now this client rect, that's the one that shows the, in the lower left corner, shows the client area. Again, copy the attributes from here, set the background color to green for this one. And the reason I'm doing that is because I wanted to be sure that this calculation works correctly. First, I make it a little bit bigger than the other one, expand by 20 from the other rectangle. This rectangle expanded by 20 in the x direction. So same height, a bit wider. Move it to the lower left of the cursor position indicator rect, and then move it one total width of itself to the left, and so it should sit right up against, just touching the black. So there should be a red and then a black rectangle, and then I put in its text. Now there's this cursor desk moves around the screen, and that's foreground color white, transparent background, and if you set the shadow color, it automatically has a shadow. Now this little bit at the beginning here, I just give it any kind of rect, because as you'll see, the way that this thing is going to work is when it moves from one place to another, it's going to invalidate the rect that it's currently at and where it's going to, and then cause a screen redraw. But that won't draw the whole screen, that'll only draw the 2 little rects that were invalidated. Now I got this hello world that sits in the upper left corner, and my line, I chose 2 points, and it's going to draw a line. Add all the controls to my list, and this here draw screen draws a full rectangle. This is drawing to the memory device contents, recall, and then draw all of the graphic objects that I have in my list. That's all there is to that. As far as processing, there's not much. As before, if I click somewhere, here's the text cursor. Let me run it. You'll see what I mean. By the text, the cursor text or desk. It's every time I click, the cursor's shape changes, and there's a little description. And the description goes sort of near where the cursor is. See, I add 20, 20. Come on. Now there's really, if this will ever build, I'll show you how the drawing works. It's really quite simple. This one, after it does its thing, it calls that draw screen, which you may think means that it draws the entire screen. So here are the two things. Here's the one, the green and black together, and they do fit exactly. If I move this over one, you would see there would be a gap. Here's the line. Here's Goodbye World, where it's supposed to be. And now when I click, there's the description. And I click somewhere else, and wherever I'm clicking, the description follows. Now, if this weren't drawing the entire screen, then clicking here and then away would have left a hole here. But in fact, it's not drawing the whole screen. It's drawing all of the elements of the screen into the memory device context, but only a little bit of it is actually getting blitted. And if I can find my cursor, I can prove that for you. Let's set it up. If I do, I'll show you. I have a thing here. I added just quickly. Flood fill on. If I press a capital A, unbeknownst to the rest of the program, the whole screen will be flood filled with white, like that. Okay, so now you see what's really being drawn. Now, what happened was I clicked here, and there was text here. It got erased, and then some text went here. Now, I don't know why Goodbye World got drawn. It shouldn't have. But I suppose it's... Yeah, now this got drawn too. I probably update their text or something. Oh, it could also be the line. You see that line? The line has a because it's slanted like that, it has a great big rectangle that, well, no, but it never gets dirty in the, refresh sense. It never gets invalidated. This is always being invalidated. In fact, the cursor's box is a special case because it doesn't call that draw the whole screen. It does its own thing all on its own. It draws a rectangle it draws its own rectangle. That's its rectangle. And then draws itself. And none of this stuff happens. It can do that because, in fact, everything goes below it, so it doesn't need to worry about anything coming above. So it's not going to interfere with it. Nothing else is going to get interfered with that it would have to, cause a redraw for. It turns out. So you see, even though, you can't tell now, but previously I wasn't drawing this full box. And as it goes back and forth, it does fill in with the background color it's supposed to. What I could do is I could make it transparent. That's the... Okay. Now somebody copies his attributes. It's right down at the end. I could sneak it in. Cursor depth. Is that going to work? It should work. It won't matter that it won't matter that it has a background brush or anything. It knows it's transparent. It won't draw that. So now, as I move the mouse around, its size will change, and its job is to fill in and redraw the bits underneath when the size changes, and that should work because it's drawing a rectangle with the current brush, the background brush for the memory DC. Okay, now how come that didn't work? That is the right one, right? Cursor depth. It is transparent. Oh, I see. That's the wrong one. It's not the one I want. I want the cursor position. This one. So you can see that here I've got a little windowing system going, almost. It has objects, and I can draw a line, and I can definitely do my graph. It's not going to be very difficult. I can draw lines and draw text, and there's nothing really more to drawing a graph than drawing dots and maybe little ticks on the line. You should be able to do that pretty easily. Alright, now let's see. It got smaller, but you didn't see any leftover bits there because it's drawing that. It's drawing all that. And now, so this is also highly efficient. Well, the only the things that are required to redraw themselves. I'm not doing the whole screen. I am doing the whole screen in memory. In the memory device context, that doesn't cost any time. It's what has to go out to the video, into the video memory that costs, and that's minimized. Let's see now, is there anything else about this? I'm going to draw a line here, and I'm going to draw another line here, and I'm going to take the data from a text file with a list of coordinates and try to find an algorithm for deciding how to spread out that text. And that sounds like the hardest problem of them all. It is a difficult problem. You know, you probably just have to make up your mind that it's always going to be in units of 2 of something or something. And then I'm going to draw the points, and that'll be the next step. All this was pretty easy and kind of fun to do. The graphics thing, the most complicated one, of course, the text, because it had there's the shadow, and sometimes it might have an invalid rect. If it has a valid rect, it invalidates its own rect as it draws, and that causes a refresh. That causes memory to get blitted to the video device. If it doesn't have a valid rectangle, then I leave it open. I don't invalidate the entire screen, and the reason for that, essentially, it's like with most of these things, I don't know for sure that that's what the user wants, right? The person using this struct may know more than I know about the situation, right? And they might know, they'll have to decide for themselves what part of the screen to invalidate, knowing that this thing has no uh, no actual rectangle associated with it. For the line, well, I mean, that's all there is to the line. Move to line 2. Oh, it's the previous, it should be called HPen pre. Set points. The only one worry about this is if it's a horizontal line, or a vertical line, what do you put for its rectangle? And so I just decided to, you can look up the width of the pen and just subtract that width from the upper the leftmost and the uppermost get subtracted that amount, and the downmost and rightmost get added that amount, and so the rectangle is never empty. And that's all there is to that. That's all there is. It's really quite, it's childishly simple, but it does seem to work. And once that's done, then we'll get on to the very interesting topic of these Hermite curves, which are behind a lot more things than you would imagine. They're everywhere, and the theory of it is quite interesting. You may think that it's like impossible and it's just too complicated and you'll never be able to learn it, but I promise you that I found this paper and it explains it so well that even a 3-year-old child can understand it. There's nothing to it at all. It's really quite interesting. All right, we'll see you later.